All right, so this video we're going to take a look at compound interest. All right, so it's going to be kind of a long video, so let's go ahead and get started. So compound interest paid once a year. All right, so this formula here, this formula is not really that big of a deal. We're going to look at this formula again after we work this first example. We'll look at it again, compound interest. This formula, you're not really going to have to, you don't really need to remember it. It's the next one. And I'll show you what I'm talking about when we get to the next example. Not this first example, but to the second example. So compound interest is interest that's computed on the original principal as well as any accumulated interest. All right. So if you deposit P dollars at rate R, where R is in decimals, okay, that's your interest rate. They'll give you the interest rate as a percent, and you need to convert it to decimal. Subject to compound interest, then the amount A of money in the account after T years is given by A equals P times 1 plus R raised to the T. So this is your formula. And like I said, don't worry about remembering this one. It's the next one that you want to remember. If you know the next one, then you'll know this one. Okay? So the amount A is called the account's future value, and the principal P is called its present value. So what they mean there, P, that's the principal, P. Now, and that should actually be principal P. All right. So for this, the principal, that's the money that you put into an account. And then after so many years that money's in there, you accumulate interest, and that interest is added to that principal. Okay. So how much money would you have in the account total? The principal plus all the interest. How much would that total? Well, that's what this formula gives you. Okay. All right. So you deposit $2,000 in a savings account, which has a rate of 6%. Find the amount A of money in the account after 3 years, subject to interest compounded once a year. Okay, so it's compounded once a year. All right, so for part A, we're gonna use this formula here. So I've got A is equal to P times 1 plus R raised to the T. Okay, all I did was write this down. So remember, P is your principal, R is your interest rate, and T is the time. T represents the number of years. All right, so let's see what we've got. So the principal P, that is 2,000. R, see, I've got to figure out what P, R, and T are. R is 6%, so that's 0.06. Remember, to convert percent to a decimal, you just move the decimal 2 places to the left. And T is the number of years. So that would be in the account after 3 years. Okay, so T equals 3. So we just plug this in. So that's going to give me A equals 2,000 times 1 plus 0.06 raised to the third. Okay. And then when you punch that into your calculator, you get A is equal to $2,382.03. So that's how much you would have in the account after 3 years at 6% if you put $2,000 in that account. Now, they want to know, find the interest. Okay, so for part B, the interest, well, if this is the amount of money you'll have, okay, then what interest do you have? Well, it'll be this total amount, $2,382.03 minus what you put in there. See, this $2,000 is the original amount, but you made this much after everything. That's the total after the 3 years. And so when you subtract them, you get your interest is $382.03. Okay. All right. So now let's look at this. Now here we go. Compound interest paid in times per year. So let me just go ahead and write down the formula from the first example. That's the formula. Okay? And remember, I said, don't worry about remembering that. This is the one that you should remember. Okay? So let's read through it, and then I'll explain why you don't need to remember that one. So if you deposit P dollars at rate R, and R is in decimal, subject to compound interest paid N times per year, okay, paid N times per year, then the amount A of money in the account after T years is given by A equals P times 1 plus R over N, and then that's raised to the NT. All right, so remember the formula up here said compound interest paid once a year. So all this is, if we look at this formula here, paid once a year, paid N times a year, paid once a year. So if it's paid once a year, N is just 1. And that would give us what? P times 1 plus R over 1 raised to the 1 times T, right? If we replace the N with 1 for being once a year. And so that would be P times 1 plus R to the T. And you can see it's just that formula there. So you don't have to remember this one, okay? As long as you know this one right here, that's the important one. Then you know if it's compounded once a year, you know N is 1, and it's going to give you, and this will give you the same thing as this, okay? And so, you might be thinking, well, why did you show me the other one? Well, I just showed it to you because it was in the book, okay? It's in the textbook I'm using to go over this stuff. So I went ahead and pointed it out. All right, so A is the account's future value. So it's the same thing as the previous formula. How much money are you going to have total after so many years? And the principal P is its present value. So P, that's how much money you're going to put in the savings account, or how much money you're going to borrow, or whatever. All right. So let's look. Well, an N is how many times it's paid per year, paid N times per year. And I'll explain that a little more. I'll explain that more as we're working through the examples and everything. So let's look at example 2. So it says you deposit $7,500 in a savings account that has a rate of 6%. The interest is compounded monthly. Okay, compounded monthly. How much money will you have after 5 years? And then find the interest after 5 years. So whenever you're working these things, just go ahead and write the formula down. So we got A equals P times 1 plus R over N raised to the N times T. All right. So now we have P is 7,500. And by the way, this is part A, is 7,500. R, that's the 6% here. So that's 0.06. T, that's for 5 years. They give us that here. That's 5. And now in this one, we've got N. So it's compounded monthly. Well, how many months are in a year? 12. Okay. So now all I do is plug all of this into my formula. So I get A is equal to 7,500 times 1 plus 0.06 over 12 raised to the 12 times 5. Put those in parentheses. And so that is going to give me, so let's see what we get on that. That is going to be $10,116.38. All right. So that's what we get for part A. That's how much money we'll have total after the 5 years. And then for part B, they want to know the interest. Well, if this is how much you'll have total at the end of the 5 years, and you started with 7,500, how much interest did you get? Well, that's just the 10,116.38 minus the 7,500. And so that's going to give me interest is 2,616.38. And that's the interest. All right. All right. So hope everything's going good. Hope you're keeping up. All right. So formulas for compounding interest. So after T years, the balance A in an account with principal P and annual interest rate R in decimal form is given by the following formulas. For n compounding periods per year, and all they're doing here is just restating that formula we just looked at. Okay, that's compounding, compound interest formula. So with this formula, we can figure out the future value if it's compounded monthly, okay, annually, which is once a year. Okay, so let's just make some notes here. So if it's compounded monthly, N would be what? 12, right? So for monthly, N is 12. Let's write it like this. N equals 12. Annually, N would be 1, or, once a year. And then we also have semi-annually. So that would be what? N equals 2. And then we have what? Quarterly. That would be N equals what? 4. And then, well, I guess probably wouldn't see it, but we could have daily. N would be what? 365, or some banks may use 360. Okay, I'm thinking if the problem doesn't tell you what N to use on daily, I would use 365, and then it may state use 360, or it may say use 365. It may tell you what to use for daily, but sometimes it won't, and if it doesn't, I would just use 365. Okay, but that's what N would be for each of those. So all of these that I've written down here, that corresponds to that formula there. That's how we would figure out what N is in the formula. And then we have continuous compounding. Okay, so continuous compounding, what is that? So continuous compounding, that's compounding interest every 1/10000000th of a second, or 1/1000000000th of a second. Okay, it's just continuous compounding on the interest. All right, and the formula for that is this right here. A equals P raised to the ERT. Okay, so in this, P is the principal, R is the rate, and T is your time in years. And E, well, E is a number. It's a number on your calculator. It's above the natural log button. And E is just a number like pi. E is equal to 2.718281828, and it just keeps repeating like that. Okay, that's the number E. But this is your formula here for continuous compounding, and this is your formula for compound interest. Okay, and then of course, whatever N is, we would have to figure out if it's monthly, annually, semi-annually, quarterly, or daily. All right, so let's take a look here at problem 3. It says you decide to invest, I guess that should be invest $8,000 for 6 years, and you have a choice between 2 accounts. The first account pays 7% per year compounded monthly. The second pays 6.85% per year compounded continuously. Which is the better investment? All right. So let's just work them separately. Let's look at the first account. Okay. So for the first account, it's compounded monthly. So that tells us that we're going to use this formula here. All right, so I've got A is equal to P times 1 plus R over N raised to the N times T. So let me come over here and get P. So P is equal to 8,000. R, for the first account, the first one pays 7%, so that's 0.07. Now let's write T down. It doesn't matter which order you write them in, but T, that's for 6 years, so that's 6. And N, compounded monthly, so that's 12. And so now all we want to do is plug all of this into our formula. So that's going to give me A equals, that's going to be 8,000 times 1 plus 0.07 over 12 raised to the 12 times T, which is 6. And when I punch that into my calculator, I'm going to get, let me see if I can squeeze it down here. So I'm going to get A equals $12,160.84. Okay. So that's what I would get. That's what I would get from the first account. Now let's look at the second account. And let's write the formula down. So I've got A is equal to P times E raised to the RT. So for this, I need P. Well, that's 8,000. It's the same amount of money in both of them. R, now R is the one that changes. It says the second pays 6.85% per year. So that's going to be 0.0685. All right. And once again, T, well, that's the same. That's for 6 years. Now, this problem, there's no N. See, we have no N in our formula. This is it. So let's plug all this in. So I get A is equal to P, which is 8,000, times E raised to the 0.0685 times 6. And then when we punch that into our calculator, we end up with $12,066.60. That's for the second account. So what they're asking us is which is the better investment. So the better investment is the first one, because see, we would get more money, okay, out of the first account than we would the second account. All right. So, the only time you're going to use this formula here is when they say compounded continuously. All right. Calculating present value. All right. Present value. So if $A are to be accumulated in T years in an account that pays rate R compounded N times per year, then the present value, P, that needs to be invested now is given by this. P equals A over 1 plus R over N raised to the NT. All right. So let me show you something about this. You don't even need to memorize this formula either. Okay. The only thing you have to do right now is memorize you need to know this formula, and then the other one you need to know is this one. You need to know that formula. Okay, so far there's two of them you got to memorize. Okay, remember the first one, I told you didn't remember that because that's just the second formula where N is 1. And then, of course, you'll need to know that one because that one's different. But this one, yeah, it's a different formula, but guess what? You don't need to remember it. So if you remember that future value, that compound interest formula, it said A is equal to P times 1 plus R over N raised to the NT, right? Well, look at this. What if I divide both sides by this? Right? Those cancel out, and I'm left with P equals A over 1 plus R over N raised to the NT, right? That's that formula right there. That's present value, okay? All they're doing in these problems, they're giving you this future value here. How much money would you have at the end of those however many years, right? They're giving you that, and you're finding out how much would I have to deposit in there right now. That's the present value. Okay, that's all it is. So don't get confused with it or anything. All right, so let's look at this example 4 here. It says how much money should be deposited today in an account that earns 7% compounded, this is weekly, so that it will accumulate to $10,000 in 8 years. All right. So let's look at it. So the key here, how much money should be deposited today? How much do I need to put in there today to have this much in 8 years? That's present value. I want to know the present value. So the present value, that's A over 1 plus R over N raised to the NT. So let's write down what we have. Well, A is what? 10,000. R is at 7%, 0.07. What else we got? T is 8. That's 8 years. And N. Now, earlier when I listed out, when I listed out monthly, annually, semi-annually, quarterly, daily, I didn't list out weekly, did I? Okay. So what would weekly be? What would N be? Well, weekly, how many weeks are in a year? Well, we use 52. Okay, so 52 weeks in a year. So now all we do is take all of this and plug it into our formula. So P is equal to 10,000 over 1 plus 0.07 over 52 raised to the n, which is 52 times t, which is 8. And then we would have to punch this into our calculator. And that gives me $5,714.24. Okay. And, you know, you can check me on that, make sure I didn't hit a button wrong on my calculator when I did it. So, but, you know, this is how you plug it into the formula. That's how you plug that into the formula, and then you just type it in your calculator. All right, so effective annual yield. It says the effective annual yield, or the effective rate, is the simple interest rate that produces the same amount of money in an account at the end of 1 year as when the account is subject to compound interest at a stated rate. Okay? It's the simple interest rate that produces the same amount of money in an account at the end of 1 year as when the account is subject to compound interest at some stated rate. So let's look at this problem. So the way that we're gonna work this one is kind of a long way, and then we'll come down here and they actually give us a little formula for it. But let's just look at this, and I think by working it out this way, it might help you understand what's going on with the formula a little more. All right. So it says you deposit $4,000 in an account that pays 8% interest compounded monthly. Find the future value after 1 year. Okay, so find the future value. So that's like the second problem that we worked. All right, so for part A, we've got A is equal to P times 1 plus R over N raised to the NT, where P is equal to 4,000, R is equal to 8%, T is after 1 year, so T is 1, compounded monthly, so N is 12. All right, so let's plug all this in. So we've worked a couple of problems like this already in this video, so plug in the 4,000 and then 1 plus, what is that, 0.08 over 12 raised to the n, which is 12 times t, which is 1. And so for this, we get A is equal to 433 to $4,332. All right. Now, that's the future value. Now, part B, use the future value formula for simple interest to determine the effective annual yield. Okay, so we want to find the effective rate. So let's go back up here. It says that the effective annual yield, or the effective rate, is the simple interest rate that produces the same amount of money in an account at the end of 1 year as when the account is subject to compound interest at a stated rate. So account is subject to compound interest at a stated rate. That's this part A. Okay, how much are we going to have compounded monthly at the end of the year? That's what that's talking about. Now this up here where it says is the simple interest rate that produces the same amount of money. So the simple interest rate, well, what's the simple interest rate? That is A equals P times 1 plus RT. Okay, that's in another video that I did on simple interest. All right, that's the formula for simple interest. So we want to know what interest rate, okay, what interest rate R is going to produce that money in the same amount of time at the end of that year. All right, so that's just 4,332, and I'm not going to put the 0.00, equals P is 4,000, right? See, there's P. times 1 plus, now R is what they're wanting us to find. And then T is what? 1. So 1 times R is just R. All right? And so now we solve. Okay? There's a couple ways you can solve it. You can distribute the 4,000, or we can come up here and divide both sides. Let's divide both sides by 4,000. All right. So that's going to give us 4,332 over 4,000 equals 1 plus R, because those cancel out. And then I'll do what? Subtract 1 to both sides. And so I get 4,332 over 4,000 minus 1 equals R. And so that's going to give me R is equal to, and then I'll do this calculation in my calculator, and that comes out to 0.083. So, and then once you get the decimal, okay, all right, once you get the decimal, you want to convert it to a percent. So that's 8.3%. All right. Now, some terminology here. The 8%, where is it? This right here, this is called the nominal rate. Okay, that's called the nominal rate. And the 8.3% rate, this is called the effective rate. All right. And that's what they wanted us to find. Now, that's how you go about working that out, using the future value for compound interest and the future value for simple interest and finding that effective rate. But then they say, okay, well, we don't want to do all that work. Here is a formula. Calculating effective annual yield. Suppose that an investment has a nominal interest rate R, that's what I was talking about, that 8%, in decimal form, and pays compound interest N times per year. The investment's effective annual yield, Y, in decimal form, is given by this formula here. Y equals 1 plus R over N raised to the N minus 1. Now, we've got a note here. The decimal form of Y given by the formula. So when you do this formula here, you're going to get a decimal as an answer. Should then be converted to a percent. And we did the same thing up here. We got a decimal here, and what did we do? We convert it to a percent. All right, so let's take a look at this example 6 here. All right, so a passbook savings account has a nominal rate of 5%. Okay. The interest is compounded quarterly. Okay, interest is compounded quarterly. Find the account's effective yield. All right. So let's see. Let's write our formula down first. So we've got Y equals 1 plus R over N raised to the N minus 1. All right. So, well, what all do we need? We need R and we need N, and that's it. So in this problem, R is what? 5%, so that's 0.05. It's compounded quarterly, so N is 4. And so now you just plug everything in. And so we get Y is equal to 1 plus 0.05 over 4 raised to the N, that's 4, minus 1. And so punching that into our calculator, 1 plus 0.05 over 4, and then that's raised to the 4th, and then minus 1, and that gives us Y is equal to 0.05 is 05094. I'll round it to 3 decimal places. That'll round to 0.051. Typically on these problems, as far as my classes go, round it to 3 decimal places. Whenever you're calculating and you're finding a percent for an answer, round it to 3 decimal places, because what that does is that gives you your percent as 1 decimal place. See, I've got 1 decimal place on my percent. Now, your teacher you have may want 4 decimal places or 5 decimal places. I don't know. But as far as I'm concerned, 1 decimal place is good enough. Okay? And so that would be your the account's effective yield. There's the 5.1%. And that wraps up this video. So I hope it wasn't too bad. Hope everything made sense. Hope you learned something. You feel a little smarter now. Check out my other videos. Give me a like, share, and subscribe. And thanks for watching.